everyone. So today I'm talking about part whole. It's something that I've gotten some questions on, and it can really help the kids with those missing add-in problems that you're seeing in the packets. Things like something plus 5 equals 22 or 18 minus what is 16. So I do have a couple addition and subtraction videos up on Dojo as well, so please make sure to look at those. But this is going to help us with this concept. So before I begin, part whole is something that the kids start learning in kindergarten. It's part of our math curriculum. And when we're talking about part whole, we're talking literally about parts of a whole. So I always tell the kids to think about, you get a pizza delivered, you have the whole pizza, and then you take a part, your mom takes a part, brother or sister takes a part. So the parts make up the whole pizza. We often use this diagram right here, which is a number bond. And we say the whole is at the top, and then there's two little parts. Sometimes they're flipped around. They could be upside down. As long as the parts are coming off of the whole, that's what we care about. When we talk about part whole, we have 4 equations that match up with it. We can add this part and this part to make the whole. We can add this part plus this part to make the whole. And then if we start with the whole and we take away a part, we end up with the other part. And if we start with the whole and take away that other part, we end up with the other part. This is the thing that kids often forget. So when we're doing missing addends, if they have a really strong basis in part whole, they can figure out all the relationships between the numbers, but they first have to have this relationship. So really quick, as an example, what we do is we give the kids examples like this. So it says part plus part makes whole for addition. So in addition, we know that when we see the plus sign, that these two numbers that are being put together make the whole. So if I was going to plug in these numbers into my number bond, I could see that 3 is a part, 2 is a part, and if I put them together, I get the whole. With subtraction, we always start with the whole. This is the one that kids get confused on the most. They'll look and they'll say that the 5 and the 3 are parts and the 2 are the whole. But if you look at it, we can't add 5 plus 3 to get 2. It just doesn't work. With part whole, the whole is always what you're taking something away from. So in this example, the whole is 5. That's the whole thing. Our parts are 3 and 2. How does this help with a missing addend? Well, let me show you. So in this missing addend equation, we know 8 plus something is 12. I see the plus sign. Because I can tell that that is the addition sign, I know that I add parts. So this part is 8. This part we don't know. And we know that this part is 12. The whole is 12. So if we're looking at this, I could then think back to all of my equations right over here that we first learned. And I could say, 8 plus something is 12. Nope, that doesn't really help me. What if I did it the other way? Something plus 8 equals 12. No, that doesn't help me. Sorry, that 8's a little weird. It's hard to write on this. The whole being 12 minus 8 could give me something, or 12 minus, sorry, that should have the question mark, something equals 8. If I look at all these equations, I could pick out that this equation shows me something I can do right now. I can start at 12 and I can take away 8. And if I start at 12 and I take away 8, I get 4. So that helps me know that this part will be 4. The same thing goes if I had a subtraction. This is the one that the kids get the most confused about. So if I had a subtraction problem, I have to remember that when I see the subtraction sign, the whole always comes before it because we're taking away from the whole. So in this problem, 12 is my whole. I don't know this part, but I know that the other part is 8. So now I could come up with my equations. I could say something plus 8 is 12. 8 plus something is 12. 12 minus something is 8. And 12 minus 8 is something. Oh, I can see easily that I could solve this equation. 12 minus 8. And I can use whatever strategy I want, and I'm going to find out that this part is 4. So when we have something like this, 7 plus 30 equals something, the kids actually have two options. They can draw themselves out a little number bond, and they can say, well, I know that 7 is a part, and I don't know this other part, but I know the top would be 30, and I've learned that if I do 30 minus 7, I'm going to get that part. But other times, the kids want to try something completely different. Maybe this is a little confusing for them, and that's okay. What we've tried to teach them is to start at 7, and we're going to add something until we get to 30. And we've done this using the arrow way. So if I'm at 7, we try to tell them to find their next friendly number. That's the next multiple of 10, the next number that ends in a 0. So the next number that ends in a 0 for us is 10. How many did it take me to get from 7 to 10? It took me 3. 7 plus 3 is 10. So now I'm at 10, and I have to get all the way to 30. Well, I know that if I added another 10, I would get to 20. And I know that if I added another 10, I would get to 30. And there we go. But now to find the answer, I have to look at everything that I added. Well, I know 10 plus 10 is 20, plus 3 more is 23. So I jumped 23. So 7 plus 23 is 30. You're also going to see sometimes the kids will jump to this 10, and then some of them just know in their head that it's 20 more to get to 30. So they'll write it like this. That's okay too. However their brains are processing it is fine. So trying this backwards, 30 minus 7, I'd be starting at 30. And I would say, if I took away 10, that would bring me to 20. Not at 7 yet. If I took away 10, that would bring me to 10. Now, here's where there's two ways to go from here. And I'm going to show you both ways. The first way is to say, okay, I'm at 10. Well, let's see. If I took away 10 more, that would bring me to 0. Oh, man, I've gone too far. So now I have to add in. Now I have to add back 7. So 10 plus 10 plus 10 is 30, plus the 7. Oh, so confusing. So what we tell the kids to do instead is to say, okay, I'm at 10. If I took away 10, it would bring me to 0. That's too many. So let's take away 1, and that would bring me to 9. Let's take away another 1, and that would bring me to 8. And let's take away another 1, That would bring me to 7. Now here's where it gets a little tricky. Even though these are all negatives, we add up how many we took away. I took away 10 plus 10 is 20, 21, 22, 23. So my answer is 23. Now the other way you're going to see kids do it, if they like this way, is to say, all right, let's see. Well, if I took away 5, or, oh man, I know that 10 minus 5 would be too many, would give me 5. I can take away 3, and that gives me 7. If they know their 10 facts, this is something that they can do. So saying 10 plus 10 is 20, minus 3 more is 23. So I hope this helped you out a little bit. I'm always here to answer questions if you have any, but let me know if you need help. Okay, great. Have a great day. Bye.